Good morning, everyone. My name is Kobayashi, and thank you for allowing me to present Sage River Disaster Information, also known as SageRDI, which demonstrates application data sharing in SAGE2. So before flooding you with information, I'd like to go over the flow of the presentation, which will include first a brief description of SAGE2. SageRDI is an application of SAGE2, so it will not work outside of it. So I feel like giving you SAGE2 context is necessary to understand what is happening. Then there's the Kawa no Bosai Jouho, so that translates roughly into River Disaster Information. It's a website managed by Japan's MLIT, which is the Ministry for Land, Infrastructure, and Tourism. Then there's the SageRDI application itself, and followed by the the components that we added to the SAGE2 system, which enabled SageRDI to work. So first is SAGE2. It's a middleware that allows you to take multiple displays, potentially across different systems, and allow you to turn them into a multi-user workspace, collaborative environment, so that anyone who's connected can interact with the display. One of the key features is that it's web-based, entirely written in JavaScript. A user needs only connect or install, rather, a web browser to connect, and then they will be able to upload content to the wall. Because it's on the wall, you will have your own virtual pointer, but you can also interact from the UI. So one of the things is that you can have multiple applications run at the same time, or when you have an application, you can have it occupy the entire pixel space on the wall. One of the key features is that it also supports multiple screen shares. So the idea is that it's a collaboration environment for which people use to investigate information. These are brief flash shots on people using it, but again, I want to stress the web aspect of it. So when people use it, one of the key features is that if you can use it in a browser or you can go to a website, Sage can then display it. And that's the lead-in into why this was kind of important for the development of SageRDI and the usage of the Kawa no Bosai Jouho website. So the website itself, before getting kind of into, I don't want to kind of rain on its parade and start criticizing it right off the bat. Actually, it's a great service, and we don't have anything like that where I live. They provide 17,000 sensors of public data available almost 24/7, and the intention is to help you with disaster awareness and how to prevent it. So that being said, it's a great service, and what we're simply doing is suggesting things and how it can improve that will then provide a greater service. So what we want to prove is that, one, it's not really designed for high-resolution environments. Actually, it's not really designed for most modern display sizes like 1080p. Second is the interaction is quite difficult to use in some cases, and it doesn't quite give you location context. So the maps aren't quite to scale. You can't figure out always what is there or how populated it is, as well as the historic data when we wrote this was limited to roughly 48 hours of information. So this is the website, and what I mean by not quite designed for high-resolution environments or your own desktop is that when you resize it, it actually doesn't do anything. So it's actually set for 1 pixel resolution, and that's it. So when people navigate with maps, you want to get information about where you are. So we're in the Chiyoda area. Typically, you go to Google, and that's kind of like the de facto standard now. And then you zoom in, you find your area, and it's kind of like this gradual go-in process. Now, the thing with that, though, is on the main page, you're presented with an interactable map. You can click on it, and then that'll show you the area. But now, further clicks do absolutely nothing. So in order to actually figure out the area that you want to view, you have to know the region, prefecture, and municipality. So in this case, we're in the Tokyo area, and then we want to go find the Chiyoda municipality. When you click on it, nothing happens. And perhaps that was my own misconceptions as well as my lack of familiarity with the language, because I do realize there is a display button. I'm not a native speaker, so it's kind of difficult sometimes. So now you're here. Let's say you wanted to go view the Kita area. That's directly north. You can't actually scroll the map. The map, at this point, you can't move it in any format. You have to then select it from the drop-down list and then choose it to get you to the Kita area. But slightly more difficult is, say, let's move from Kita to Kawaguchi. That's a little bit more north, but you can't select because it's in a different prefecture. So you actually have to select Saitama from the prefecture list, then select Kawaguchi. And this would be further complicated if you actually switched regions, because there, if you'll notice, there is no drop-down tab for the regions. Then there's the sensor data information. So this was perhaps an unfortunate, while I was trying to do a screen recording, but maybe fortunate for the sake of presentation, is in order to view sensor data, you have to hover over the sensor icon. It'll pop up a box, then you click on the link. But if you're ever, don't put your cursor on that pop-up box, it goes away. This is exaggerated. I'm going to admit this because I put it on a loop, so I didn't do that the entire time. But so say you finally get there so that you can click on the link. It opens, in this case, a new tab. And OK, fine, no problem. There's nothing particularly bad happening within the past 24 hours, so that's why there's nothing spiking. But say you go to this one and you click on it, it doesn't open a new tab. Actually, what happens is that it updates the bottom right. So that sensor does open a new tab. The previous one didn't, and there's sometimes this inconsistency between which icons and which information pieces do what. OK, so we would like to then present the, at time of submission, the version of SageRDI to try and address these issues. Testing earlier, there was no audio, so I'm going to be talking over it to kind of describe what's happening. We added voice commands with into the system, the Sage system. 1 second. Into the Sage system to help with interaction flow. So that way people don't have this disjoint thing between I'm looking at my laptop versus I'm looking at my the wall. So you can launch it with voice commands. The center one is the main application. The 8 windows around it are supporting applications to show the sensor information when you click on the map. So we added that. That doesn't actually exist on their website. But now you've got a full panel view of the sensors, and you don't have to worry about this, where did my data go? It'll clearly mark where it is. Each of those windows can also, each of those windows is for a sensor, which can then be displayed on a Google map. So the idea behind this is, where is that? What is the location like with the Google map? You can zoom in as much as the Google map allows you to. You can zoom out. You can then move with the Google map to alter the view of the website's display page. So as the Google map is moved, we send the information back to the application so it can query up the correct information page from Kawanobosai. So part of this is only possible based on a previous data scrape. So for example, this click into the map, we can get the data out of it. Each sensor has a GPS location associated to it. And when you click on it, we can then send it to the map so that when you click there, the Google map will update to show you what has been selected. So this is just showing that as we go north over Japan, the main page in the center will update to show the correct information page. Then some of the people who we were collaborating with was interested in, how are these sensors doing? Like, can we link it further with the current weather search? So as we moved throughout the different places in Japan using searches, so that was to Kyoto, then the weather search will update to show you roughly the prediction for today's weather. And then you can query the information on the sensor list to see if they match up at all. So with the information that was gathered, part of their intention was to evaluate like how clean is the information, how can they present it, or how reliable is it. And part of it is that not all the sensors that they observed had data on our previous pass, so it might be new, it might be missing, it might be perhaps not clean data. So they wanted the ability to flag it, or if it had data, the ability to review the historic data. So the historic data is from our previous data scrape that doesn't actually exist on their website. But using it, you can then have an evaluation perhaps of, is that normal for that sensor? And when charts are generated, each of the charts for the sensors are linked. You notice they are popping up, so the system is in control of roughly the position, and then I can go in with the cursor and modify it. Each of the charts are synchronized so that their view is maintained. You don't have to go to each individual chart to keep them with the same view. Okay. So there's 3 main components that are necessary for it to run: the script injection, communication with other applications, and the prior data scrape. Now, the script injection is stressed a little bit hard on this because we don't have access to their servers. We don't actually have any partnership or communication with them other than the fact that we showed them, hey, look, it exists. You can do this. Please make an API. So actually, that was one of the driving factors behind this, is that they don't have a public API. And we were trying to find ways to convince them to open their data, as well as perhaps even if they have a historic set of data. That way, you don't have to have individuals tracking it themselves. So part of the script injection was easier interaction. The click on the map to show the sensor data doesn't exist on their web page. We created that ourselves and we were able to do that by knowing how they format their website. So admittedly, it does take intimate knowledge sometimes of how they created their things in order for our parts to work. For the data communication, it is two ways. So both the application can send to the Google Maps or other applications, and then other applications can send back. So when we combine that, then we're able to use the movement of the Google Map to adjust which information page you're looking at for the sensors. And without the data scrape, we can't really show the historic data. But they are using the data sharing aspects in order to synchronize their view. So the architectural additions to SAGE2 is arguably what we're really trying to show off in this particular paper, is that there's now abilities for applications to launch other applications. Before, they used to be considered independent, separate, and segregated. So parent-child relationships allow applications to launch others. And kind of due to the abusive nature of JavaScript, you don't have to rewrite the entire code base in order to allow them to directly interact with each other. Then there's publish-subscribe systems, which allow data to persist beyond an individual application, or applications to generically broadcast information without perhaps knowing ahead of time what they may or may not be allowed to do. So in that case, the idea is creating a general aspect of data sharing so that applications can be developed as components and widgets rather than all-in-one pieces. Finally was the voice commands. So for voice commands, we tried to make it generic such that it will work beyond our system based on the UI context menu and the user capability system, which is a pre-known and pre-known list of values, such that when we do the conversion, when you click over an app, you can tell it something, the converter will process it, look up all available commands for that application, try and match it up, and then issue the command. Based on informal feedback and observations, so actually we did not have a formal user study for this. We had sort of a back and forth between those who were involved in the process. But the feedback we got was that it was easier to traverse between municipalities. So one of the key things being that people just go north or east or west, and it wasn't as big of a problem as having to mentally think about, okay, where do I need to go? What subdivisions do I have to go through to get there? Then the other aspect was because a lot of the authors don't read Japanese, including myself. I can't quite get a lot of the characters. Those who don't have any know-how of how to read the kanji, they can use it mostly without a problem. The click interaction was easier to update than having to fuss with that whole pop-up menu thing. And it was easy to, it allowed those who evaluated it to find problems with the sensor data. So one of the immediate things that was actually a big issue was all the sensor GPS locations, latitude and longitude, was flipped. And that kind of confused us at first, because when we first plotted the sensors, they just didn't show up on the Google map. So that's one aspect of things where, even though the website has it and it shows it, that image they show is actually hard-coded in some way, and it's not necessarily correct to what the data they put inside it related to. So some were actually in the ocean according to their GPS locations, or even not in Japan. Voice commands increase user engagement. Originally, we did it mainly to ease the transition so they don't have to fuss with their laptop. They just remain in virtual pointer mode and interact with the application. But we found that actually people became really interested in finding obscure locations or looking for sensors in odd places. And I don't know if it's perhaps a language thing, but people became very understanding if it didn't understand what was said. So as an English speaker trying to pronounce a Japanese location, they're like, oh, okay, that makes sense that it got the wrong thing. And even as a Japanese speaker who evaluated it, the weird part was because it was an English application system, they were kind of okay with it missing. So for future work, we wanted to conduct a future formal user study, improve work on the script injection, and in particular with how the data can be communicated inter-app. So one of the goals behind this is that a lot of web pages actually have data. D3 is a really well-known piece that's actually formatted pretty well. I mean, they have their own formats on an individual website basis, but with the ability to extract that data, you can then toss it on another application. Opportunities with another project was LandSage, so it's a landslide-related disaster relief, and the intention is to improve the voice interaction to allow Sage to be a collaborator in your meeting or investigation. Thank you.
Okay. Anyone have any questions? Nobody? Oh.
Sorry. Hi, it's Stacey Scott at University of Guelph. I thought this project was very interesting. The original SAGE system you showed seemed like a desktop system. Is that true?
Correct. So it's actually a web server. Most of what you can do to get the tiled system working is you create viewports into it, and actually the viewports are either modified browsers or you can use the Chrome system but with reduced capabilities.
So is it
Chrome browser with
typically used, to your knowledge, as a single user application?
No. Typically it's used in classroom for teaching environments, brainstorming, investigation, and remote site collaboration.
So it is used for collaboration, because it just seems like the system you were showing, especially the click-click interface, was very much a single user interface, but the redesigned system was very much this big wall.
Right. So I think part of perhaps what's causing confusion is that people haven't, users of the Sage system have their individual UI view on their laptop. So most of the time what they'll be seeing is a personal view. And then the wall view is what's shared between all users.
Okay, thank you.
Okay. No more questions. I have just a quick one about the voice command thing. How complex was the grammar of the voice command, and how could people learn what to say to the system?
Admittedly, it wasn't really that complex there is no grammar system. It's a word count system. So we use it by keywording actions inside of both functions and context menus. So honestly, there is no NLP to say like, okay, noun, subject, verb, etc. It was more like you said this word, closest match up to command list inside of application with density. So the more words you get, the higher the match rate.
Okay, cool. No more questions? Okay, then let's thank our speakers.